Relative sort array. In this problem, we're given two arrays, array 1 and array 2. The elements of array 2 are distinct, and all elements in array 2 are also in array 1, which is important and very helpful for us. What we need to do is we need to sort the elements of array 1 such that the relative ordering of items in array 1 are the same as in array 2. Elements that do not appear in array 2 should be placed at the end of array 1 in ascending order, which is also important. So in example 1, we have array 1 with a list of all these numbers. We also have array 2 with a list of these numbers. What we need to do is we need to sort array 1 to follow the pattern of array 2. So what that means is, since array 2 begins with a 2, we need to find all the 2's in array 1 and basically put them together. And then what follows the 2 is 1. So we need to find all the 1's and then put them after the 2. Then is the 4, so we put all the 4's after the 2 and then the 1's. And then we have 3, so we have to put the 3's after 2, 1, 4. And then we have to put all the 9's after all the 2's and all the 1's and all the 4's and all the 3's. And finally, we need to put all the 6's after all those numbers that I just mentioned. And as you can see, the output is 222, 1433, 96. Now we have two numbers in array 1, the 7 and 19, which do not appear in array 2. And what we need to do is we need to sort them in ascending order at the end of the list. So after we sort all the numbers in the pattern of array 2, we need to put 7 and then 19 right after all the sorted numbers of array 1 and array 2. And of course, the number of times that they do appear. So for example, we might have multiple 7's or multiple 19's, and we have to make sure we include them all as well in our output. So to give you a quick brief on how we're going to solve this, we're going to create a map. In the map, we're going to put all the numbers of array 1 as a key, and their corresponding values are going to be their frequency or the number of times that they appear in array 1. So for example, we're going to have a key 2 with a value of 3 since it appears 3 times, a key 1 with a value of 1 since it appears once, and so on. Now we don't need to create a new array. We can simply override the values of array 1 since we have all the values stored in our map, so there is no risk of losing any values by overwriting them. What we're also going to do is we're going to create an int variable called x or l or I, doesn't really matter. But what this variable is it's going to basically point to the current position that we are in array 1. So we're going to have, let's call it int x, which is equal to 0, meaning we're looking at the very first element in array 1. And what we're going to do now is we're going to look at array 2. And for every number in array 2, we're going to replace array 1 at index x with the number that we're looking at in array 2. And then we're going to increment our x variable to point at the next element. And we're going to keep replacing values at position x with the number at array 2, the number of times that the number exists in array 1, or the number of times that the number that we're looking at exists now in our map, which is the value. And after we've incremented x the correct amount of time and added the number that we're looking at the correct amount of time, we can finally loop to the next element of array 2 and repeat this process. Now in the end, we're going to check if our variable x is equal to the length of our array 1 minus 1, because indices in Java start at 0. So since we started x at 0, we need to check if by the end of that process, which I just mentioned of replacing variables at position array 1 at x, we have to check if x is equal to length minus 1. If it is, that means we've checked every number in our map and every number in array 1, and we can just return array 1. However, if it's less than array 1.length, that means we still have some variables or some elements that we have not accounted for, and we need to take care of that. And actually, we're going to take care of that in that long process which I spoke about when looking at the number at array 2 and then replacing it back in array 1. Now let's go ahead and begin coding, and everything will make sense, and I will explain as we go along. So the first thing we're going to do is we're going to create our map. So map, which stores a key value pair of integer to integer, key being the number we're on, the value being the frequency or the number of times it appears. Let's call it map is equal to new tree map. So why are we using tree map? If you recall in the description, they mentioned that elements that do not appear in array 2 should be placed at the end of array 1 in ascending order. Now what tree maps do is they sort keys in ascending order. So basically, once we reach the stage where we check if x is equal to length minus 1 and find out that it's less in some examples, when we need to add these elements to the end of array 1, because we're using a tree map, we've already actually taken into account the ascending order constraint, and so that's why we're using a tree map. Now what we need to do is we actually need to fill our map with key value pairs. So let's go ahead and do that. For every int number in array 1, map.put the current number that we're on as a key, and as a value what we're going to put is map.get or default. So as a value we're going to either map.get the value of number if it already exists in our map, and if it doesn't, then we're going to map or default to 0, so assign a value of 0 to the key number if it doesn't exist in our map. And in the end, regardless of whether the value of whether a number exists already in our map and we can retrieve its value, or we have to default its value to 0, we need to add 1 to account for the current number that we're on, and then we can exit this for loop. So now we have a filled map with key value pairs. What we're going to do now is we're going to create our int variable x, which is equal to 0. And we're going to begin looping, or we're actually going to begin looking at the elements in array 2. So for every int number in array 2, now what we're going to do is we're going to create another for loop for every int I equals to 0 as long as I is less than what? Map.get. So map.get the value of number, which is the frequency of number, which is the number of times it appears in array 1, I++. We're going to replace the element at array 1 at index x with number. We're going to increment x, and then finally we're going to map.remove number. So I didn't explain what map.remove number does in my brief explanation of the solution earlier, but before I do that, let's go through this for loop. What we're doing is we're going to loop through all the elements in array 2. Obviously, in this example, we're going to start at 2. What we're going to do is we're going to, in a nested for loop while I, which initially is equal to 0, is less than map.get the value of number. So while I is less than the number of times that number appears in array 1, we're going to replace array 1 at index x with number. So you can imagine in this example, we're looking at 2. Map.get2 is 3 since it appears 3 times. We're starting at I equals 0. Array 1 at index 0, because remember x is at 0 in the beginning, is equal to number. So we're going to replace this value in array 1 with number, which is 2. Now, coincidentally, it's also 2 here. And then we're going to increment x. So now we're looking here. I is now equal to 1. Is I less than map.get value of number? It is. 1 is less than 3. So we're going to replace this value with 2 as well. And then we're going to increment x to look here. Once again, we're going to replace this number with 2, increment x. After replacing this number, or this index, and we reach here, we notice that I is actually equal to map.get value of 3. So we exit this for loop. And then this important statement, map.remove number, what we're doing is we're removing the key, or we're removing the number which we're currently looking at array 2 from our map. So in our map, we had a key 2 with a value of 3. We had a key 1 with a value of 1. We had a key 4 with a value of 1. We had a key 3 with a value of 2, and so on. Once we do map.remove number, once again in this example, map.remove 2, we're removing 2 from our map, and then what we're left with is all the key value pairs of all the other elements. Now, why is this important? This is important to us because once we check if x is less than length minus 1, which means we have numbers that we have yet to account to in array 1, the only numbers or keys that are going to remain in map are the ones that we did not remove, because remember, map has all the key value pairs of array 1, which includes the numbers that are not in array 2. And since we're using a tree map, these numbers are already sorted in ascending order, and so all we need to add is those remaining numbers, and of course the number of times that they appear in array 1. So now once we exit this nested for loop, which is right here, we're going to check if x is equal to length minus 1, which means we don't have any extra elements that we need to account for, and we looked at every element in array 1, or we sorted every element in array 1 according to array 2, and all we need to do is actually, let's remove the brackets, and just to make it cleaner, all we need to do is return array 1. Now else, if it's not sorted, which means we still have some numbers that we didn't account for that don't show up in array 2 but they exist in our map, we need to sort of replicate this nested for loop process. So let's take a look at what we need to do. So for every int key in map.keyset, these are the remaining keys, remaining numbers in our map after we remove all the keys that we sorted out in array 1. So for every int key in map.keyset, once again, for int I equals to 0, as long as I is less than map.get the value of the key which we're on, I++, array 1 at x is going to be equal to key x++, and there is no longer a reason to do map.remove. And after we exit this for loop and this else statement, or actually within this else statement rather, all we need to do is return array 1. So this is the full code. Let's go ahead and submit it and see if it works. Okay, small typo mistake. We don't have an int variable called length, but rather what we need to do is we need to do array1.length. So let's submit again, and there we go. So that was the relative sort array problem on LeetCode. I hope you found that video helpful, and thanks for watching.